These are a few snap-on ferrite cores or beads which I bought online today. This is the end-on view of a snapped one, and this is the open view, and it is the other side. So you can see how it will work. You can close this and snap on so that it will appear like this, and the cable will go through this. I checked with my cables. It will snap on my HLF 200 cable, which I use for my IC2730 dual band VHF radio. But it will not be enough for my RG213 cable, which I use for HF radio FT710, just because this groove is not thick enough. RG213, as you are aware, is a very thick cable, so it will not go through this. So I can try this only for my VHF radio, and after that I can also use it for maybe the interconnection cables, that is cables which we use for connecting radio to the computer and other devices. Before using these ferrite beads on my cables, I thought of checking how much their magnetic properties are there. This is a coil which I have wound earlier for my loaded coil dipole, and my LCR meter shows it has 123 microhenries of inductance. Now I am introducing a pencil which has graphite into the coil and seeing what happens. There is very little change in the inductance. Next, I am going to introduce this ferrite bead into the coil. Let us see. As it goes inside, you can see the inductance is increasing, and it has come to 147 from 123, 149, 150. The more it goes inside, the inductance increases. It has reached the other end, so it's partly outside the coil, so it has decreased. I'll bring it back. So about 25-27 microhenries of inductance has been added by just introducing one bead inside. Now I am going to introduce one more, but this one is open. That's because once you snap it inside, I don't know how to open it again. I am going to push it. So adding one more ferrite bead has brought the inductance up to 189. You can see that pushing the third one inside will take the range beyond. Now 1 is displayed. That means after 199 it has gone to 1. 1 is error value because what I have chosen here is 200 microhenry range. So the inductance from 123 has gone beyond the 200 microhenry range. That's why this error value of 1 is being shown. Now I have taken the ferrite beads outside. You can see that the inductance value has returned to the previous value of around 123 microhenries. So these beads have some effect. Now for a comparison, I am using this plier, this iron. It is not ferrite. As I introduce that inside, you can see that inductance is increasing, but not as much as the value which you have seen for the ferrite beads. I'll try introducing this screwdriver also. This is an iron screwdriver, and I am introducing to full extent. Now the value has gone up to 157. when I am introducing a small screwdriver, or rather tester cum screwdriver, the increase is very minimal, and that is expected also. It will depend on the amount of ferromagnetic material which goes inside the coil and the magnetic permeability. The usual magnetic permeability of iron is less than the ferrites. That's why ferrites have shown more of increase in inductance. That's what exactly I want also, because that will probably cut some RFI or radio frequency interference in my radios. I'll test that in the evening, because this snap-on beads are suitable only for VHF radio, that is HLF cable. It won't go for the RG213, and noise in my VHF radio appears in the evening, so I'll test that in the evening and report later on.